So here in this problem, we need to check whether these 3 points are collinear in nature or not. Collinear means the points must lie on a straight line. So what we'll do, we are going to give name to each of the coordinate point. So we have point A, its coordinate being 1, 1. Then we have point B, -2, C is 7. And then we have point C with coordinate 3, -3. So what we'll do, we'll try to find out the length AB. We'll try to find out the length BC, and we'll try to find out the length AC first. So let's do that first. So here what we'll do, we'll use the distance formula. The distance formula states that if we have 2 points, point A with coordinate x1, y1 and another point B with coordinate x2, y2, then the distance between the point A and B, which is a straight line, that's given by the distance formula, which is square root of, so underneath the square root, we take the difference of the x coordinate, square it and add it to the difference of the y coordinate and square it. So this will be equals to, so here we have point A and point B. So let's apply the distance formula. So AB means we'll consider B first and then we will come to A. So B, the x coordinate of B, that's -2. From here, we're going to subtract the x coordinate of point A. So that's -1. We're going to square it. Then add it to the difference of the y coordinate. Since we are using AB, so we'll work with B first. The y coordinate of B, that's 7. From here, we're going to subtract the y coordinate of point A. So that's 1. So we have 7 minus 1 whole square. Let's find out this value. So this will be equals to, underneath the square root of -2 minus 1, that's -3. -3 squared is going to be +9. Plus we have 7 minus 1, so that's A is 6. 6 squared is going to be 36. So this becomes equals to square root of 45. Fine, so let's keep it aside. Now coming to BC. So BC will be equals to, we'll take the square root underneath the square root first. We'll have to start with C since we are considering BC. So C, the x coordinate is 3. So we take 3 and from here subtract the x coordinate of B. So that's -2. So negative of -2 will make it positive. So we have 3 plus 2 whole squared. This will be added to now the difference of the y coordinate. So we'll have to start with C. So we have taken -3. We have -3 minus the y coordinate of B. So that's 7. So we have 7. -3 minus 7 squared. So let's find out the value. 3 plus 2 squared, that's 25. Plus -3, -7, that's -10. -10 squared, that is 100. So this will be equals to 125. So this is simply 5 square root of 5. Coming to the final point, AC. So AC will be equals to, we'll take the square root. Since we're considering AC, so we'll work with C first. So the x coordinate of C, that's 3. From here, subtract the x coordinate of A. So that's 1. So we have 3 minus 1 squared. This will be added to the difference of the y coordinate. So we'll have to start with the y coordinate of C. So that's -3. From here, we are subtracting 1. So we have -1 squared. This will be equals to, so we take the square root. So with 3 minus 1, that's 2. 2 squared will be 4. Added to -3, -1, that's -4. -4 squared, that's 16. So 16 plus 4, that's 20. So we have square root of 20, which is nothing but 2 times square root of 5. Okay, we can also simplify a square root of 45. So that simply equals to 3 times square root of 5. Okay, so here we have obtained that AB has a length 3 times square root of 5, BC has a length 5 square root of 5, and AC has a length 2 times square root of 5. Since we can clearly say that BC, the length of BC is equals to AC plus AB. ABC, that's 5 square root of 5 equals to, so AC we obtained, that's 2 times square root of 5, and AB is 3 times square root of 5. So when this criterion is met, we can clearly say that point A, B, and C must be collinear. That means they must lie on the same line. Therefore, point A, point B, and C, so these are the 3 points. So these 3 points are collinear.